Good evening and welcome to the sixth program of the World Affairs Council of Western Michigan's 2028 week Great Decisions series with topics suggested by the Foreign Policy Association of America. I'm Michael Van Denen and I'm the Executive Director of the World Affairs Council. On behalf of my colleagues Erica Kubik and Emily Smith and the Board of Directors of the Council, I welcome all of you. And thank you for adjusting as we program responsibly in this time of COVID-19. And we hope that you will stay safe and you will show grace to those in your community. Council's mission is to empower the people and organizations of West Michigan to engage thoughtfully with the world. We do this through the support of 50 local organizations and companies, and 11 educational partners and many community members. Together, we seek to provide programming that is credible, objective, that is relevant, civil, and compelling. To change the world, we believe, you first need to know the world. Tonight, we say thank you to Wolverine as our series sponsor, to Arconic as our live stream sponsor, to Blue Lake Radio and the Community Media Center as media sponsors. And our special gratitude tonight goes to Dorner Works and Montcalm Community College for being topic sponsors. After Ms. Sheppard's presentation this evening, there will be ample time for questions. You can type them into the YouTube comment section, or you can text them to 616-308-6560. Please exhibit civility to our guests and hospitality to others by asking respectful and succinct questions. Tonight, we're pleased to have Lindsey Sheppard with us, and we are grateful for her flexibility to engage us in this format. Lindsey Sheppard is a fellow with the International Security Program at the Center for Strategic and International Studies, CSIS, where she focuses on emerging technologies and security applications. Her research areas include artificial intelligence, machine learning, defense innovation, and technology ecosystems. Ms. Sheppard contributes expertise in modeling and simulation, system architecture and design, electronic warfare, and radar from 5 years of experience in defense research and development. Before joining CSIS, she was a member of the technical staff of the Charles Stark Draper Laboratory and the Georgia Tech Research Institute, during which time she served as the systems engineering lead on multi-year efforts building simulations capabilities to evaluate technology and deployment solutions to support military operations. Ms. Sheppard holds an MS and a BS in aerospace engineering from the Georgia Institute of Technology. And her presentation tonight is entitled, "The Future is Now, Artificial Intelligence and National Security." And now we welcome Lindsey Sheppard.
Wonderful. Thank you so much for having me on. It has certainly been an interesting time as we all adjust to our new normal. So I think it is apt that we are doing a technology discussion via YouTube and Zoom, and we're all just trying to figure it out. So thank you so much for having me. I'm really glad that we were able to work this out after all of the fun with travel cancellations and travel policies and whatnot. So I'm going to do about 30 minutes of remarks, and then that will save ample time for questions. And it's a broad topic, so we're going to touch on a lot of things very lightly, but hopefully my goal is to give you a lay of the land of what are the key points, the key concepts, who are the primary actors, what are the big trends, what am I personally looking for from my position at CSIS as an analyst, and then hopefully we'll open it up and maybe we can dive into different topics and questions. So just as a background, thank you for the wonderful introduction. So I joined CSIS, which is the Center for Strategic and International Studies, from a previous career in defense research and development. So I was working on engineering problems at the early concept development, doing a lot of modeling and simulation and programming and project management there. CSIS was a bit of a career change for me. So it is a nonprofit, bipartisan policy research organization And we as an organization conduct independent analysis and research to address our national security challenges. So my research really focuses on the nexus of national security policy, emerging technology, and defense, drawing on my expertise from defense R&D. And it's really a unique time to be in this field, to really bring together both the technical worlds and the policy worlds to have discussions. So my broader expertise and research area focuses on how U.S. allies and partners can leverage new capabilities, what has to change for them to do so, but also how are our competitors thinking about new technologies. So one of the big topics that always comes up is emerging technology. So what is an emerging technology? What counts, and where is the United States prioritizing? So there is no agreed upon or set definition for what an emerging technology is. Often you will see artificial intelligence and machine learning, robotics, biotechnology, quantum computing, nanotechnology, directed energy weapons, hypersonics, low-cost space systems, blockchain and cryptocurrency, 5G and the Internet of Things are often included. And so it's really it's an interesting phrase. I find it a little problematic because some of these technologies are quite new. Some of them are quite immature. Quantum computing is still very much at a proof of concept phase, whereas many of these technologies I would consider have emerged. Artificial intelligence and machine learning, while we were still doing research, has been a field of study for decades. But I think the important distinction to draw is a split between some of these technologies. Some of them are still heavy on research and development needs. They're very capital intensive, and they may have in the near term low returns on investment. So thinking quantum computing, 5G, hypersonic, directed energy weapons. But there is an entire class of emerging technologies that are very low cost, easy to access. They are software driven, they are data intensive, and from a security or defense perspective, many of these are dual use. And so that's, I think, the really important distinction to be able to identify on these emerging technologies is where is the heavy R&D capital intensive, but where are many of these technologies being driven by the commercial sector, by software, and by the increasing availability of data. And so all of that software driven technology and data is not just about artificial intelligence. It really fits within the broader societal transition to a digital economy or to digital economies, moving from the industrial age to the information age, of which artificial intelligence is simply one of those pieces of the puzzle. But the talk tonight is on artificial intelligence. So that's where we're going to focus. As a caveat, this is going to be a bit more focused on national security and defense. There is, of course, immense development in the commercial sector. The broader federal government sees many advantages to using artificial intelligence. But from my focus area, working primarily with the Defense Department and our intelligence customers, it's really, that's my focus area. So what is artificial intelligence? It is often a buzzword, and we are increasingly paying more and more attention to it. But I think it's important to remember that artificial intelligence itself is an umbrella term. It can be used to mean a field of study in computer science that lumps together a variety of disciplines. You'll hear machine learning, which is the algorithmic way using data and algorithms that you can replicate intelligent function in machines, so you can actually improve your output with your set of inputs as opposed to having kind of a static set. Computer vision, the ways by which a computer identifies an object in an image. Natural language processing, the ways by which computers can process and understand, if you will, human, both written, auditory, and spoken language. There's a few others that really only get love within the AI community: knowledge representation and automated reasoning. So how computers actually understand knowledge. And then robotics and autonomy. Robotics is also lumped in with artificial intelligence. It can also be used to mean a variety of use cases. such as facial recognition, which combines machine learning with vast amounts of video or imagery data and computer vision to actually detect objects in those images, or autonomous vehicles, which would implement some type of learning functionality, again, through machine learning, particularly if you think about the use of how Waze or any intelligent navigation would improve its performance over time. It can also be used to reference fictional or far-off futuristic capabilities, such as the Terminator, which always comes up in these conversations, or artificial general intelligence, which is, as far as I'm concerned, is probably as far outside of the scope of my daily research. I personally don't think I will ever see it, but who knows? So in our report from CSIS, we had a 2018 report on artificial intelligence. We offered the following definition that really captures where we are with AI today. It is a purpose-built, problem-specific algorithm or agent. It's important to remember that AI is fundamentally software, though it does require hardware components and computing components. But really, it is math and code to make decisions about data that implements the functionality of cognitive task execution in machines. So it's important to remember, as many of my colleagues have noted for years, that artificial intelligence is not magic. It's just mathematics. So how are we thinking about using artificial intelligence for defense, particularly from the US perspective? So the US is thinking primarily from a human-machine teaming approach. So we're thinking about how do we take this technology, these algorithms, the vast troves of data, how do we actually allow our men and women to do their jobs better, often tackling questions of optimization and resource allocation. How do I do things optimally given some objective measure of performance, or how do I minimize losses or maximize returns? So the areas where these problems exist are not always the ones we immediately think of. So maintenance and logistics is one area where we see vast applicability for machine learning. So doing predictive analytics, anticipating component failures or repairs, or actually repairing things before they fail so that you're actually maintaining the uptime of your systems. Cybersecurity is one area where we see machine learning in particular being applied. Globally, most major cybersecurity firms are all incorporating machine learning into their threat detection approaches. Humanitarian assistance and disaster relief is one area where we're seeing a lot of movement, because essentially it's a giant optimization problem. How do I get to people faster? How do I move my resources more optimally? And there are some really creative uses of machine learning in that space. For example, there's a recent Defense Department project to do fire line mapping, where they would send out small drones that are taking imagery of a space and are actually mapping how a fire is progressing, and that data is then relayed back to first responders. Personnel management, human resources. How do I more optimally manage my force? How do I put people in jobs where they are best suited? How do I make sure that people are getting the best return from their professional development? It's really a big data problem. The US does continue to look at ISR, so intelligence, surveillance, and reconnaissance, which was the first big public use of artificial intelligence out of the Defense Department. From a kind of like broad perspective, we think about the way the United States is focusing on artificial intelligence in defense research and development, as well as federal research and development. Both of those are on the uptick. Both are receiving heavy prioritization through the various budgeting cycles. This year, the president released his budget request, which saw an overall increase for artificial intelligence, though it did actually result in a decrease across the board for many other areas. But the US is on track to double its non-defense spending on AI research and development and initiatives by 2022. So how are others thinking about AI, and how do we view that, or how do we compare it? So across the board, all of the allies and partners and peers of the United States are thinking about artificial intelligence. And they're all thinking about it in ways that reflect their national goals and norms and standards. The Five Eyes Alliance, Intelligence Sharing Alliance, so the UK, Canada, New Zealand, Australia, the US, are all having conversations on data sharing and bringing in artificial intelligence. Our European partners in NATO are all thinking about how do we bring in artificial intelligence, not just for national security, but also for commercial. France, for example, just released its AI strategy on national security that actually very closely, I think, mirrors how the United States is thinking about its approach. Some countries, such as India and the Republic of Korea, are heavily focusing on a tech replacement strategy, so leveraging robotics and other AI technologies to really make up for either a lack of personnel or a lack of capability, to really kind of build up that capability and punch above their weight. The Middle East also, many nations, particularly the Gulf nations, are seeing that artificial intelligence is going to be an integral part of digital economies. So that brings us to kind of the two obvious nations that I left out of that list would be Russia and China, who, along with the United States, have been, I think, the most vocal in their ambitions and their focus on artificial intelligence. Vladimir Putin is the originator of the quote that whoever dominates AI will dominate the world. And Russia has been increasing its focus and investment on AI strategy over recent years. They are thinking about how do they incentivize STEM talent and workers to stay in Russia and to spur innovation, increasing their internal investment. China notably has declared itself its goal to be a global leader in AI, heavily prioritizing autonomous systems, what they call the intelligentization of systems, as opposed to the informatization of systems. So bringing in that intelligent functionality in addition to just the data-driven functionality. And then, of course, we are seeing nations increasingly work together to accomplish their artificial intelligence goals. Russia and China are increasingly prioritizing partnerships among themselves, looking at AI, robotics, and big data through dialogues and exchanges, joint development funds, competitions, academic competition. And so across the board, it's difficult to say and assess a true value on, what does the financial investment of 1 billion get you versus 1.3 billion, or what does it mean to say that, Russia is investing 6.1 billion over 6 years versus the United States investment. But I think the important part is to recognize that these trends show a clear prioritization, as well as an increase in focus and allocation of national resources. It's not just enough to have that sustained investment and focus, but there is an increasing dollar amount and focus. So how is the US thinking about its focus and investment on artificial intelligence, and how should it think about it? As I mentioned previously, we do continue to have a strategic priority on federal and defense research and development. But really, and I think what we're starting to see reflected across both the federal non-defense and defense approaches is the United States looking throughout the artificial intelligence ecosystem. So if you think about how we have ecosystems in nature, artificial intelligence could be said to exist within its own ecosystem. It's not just the algorithm that one is developing, but it is the workforce, everyone that touches it, the developers, the users, the project leaders. Particularly for defense, we see even people that wouldn't be using artificial intelligence in their daily lives still have a role to play in getting artificial intelligence into the Department of Defense. So it's that computing infrastructure that artificial intelligence relies on, particularly when you're looking at those very data-driven techniques, such as machine learning, computer vision, and natural language processing. A lot of updating that computing infrastructure requires information technology modernization, that becomes a critical component for enabling artificial intelligence beyond just doing your algorithmic development. And as I'm sure we are all familiar with, IT modernization is never an exciting topic that anybody wants to take up, but it is absolutely one that is critical to bringing and adopting artificial intelligence for national security. Increasingly, we are thinking about how do we have policies and guidance and regulations that that direct how we use artificial intelligence. What are the best places to use it? How do we even think about governing this technology, or this word that is often used to encompass many different things? Does one write a policy and guidance on facial recognition, or does one write a policy and guidance on when to use machine learning in a targeting cycle? That's where having that AI literacy becomes increasingly important to really have productive conversations and discussions about where policy and guidance goes. And it's important to remember that, you know, through that ecosystem view, you see that AI is really a tiny part of the AI puzzle is the technology and the algorithm, and that many of the greatest challenges that exist around it or many of the greatest challenges are those that actually exist around it. So the time, the data, the cost, the talent. And that's not to be said that there aren't challenges with the technology. I think there is, particularly given how relatively immature this capability is, there is a tendency to overestimate and potentially misapply due to that overestimation of the capability and the repeatability, particularly for defense applications. So, and even when we think about employing AI where it works, so we've found good problems in maintenance and logistics, or we've found good problems in cybersecurity, it's important to remember that AI is also not foolproof. Machine learning in particular brings in new ways to be exploited, that systems could be attacked or defeated or exploited. I think we're all pretty familiar with the often used example of fooling an image recognition algorithm on a vehicle by placing a sticker on a car. So it's important to remember that those types of failure modes exist in any system that brings in artificial intelligence. That broad tackling of the changing nature of work in the information age is posing challenges for all nations that are looking to apply artificial intelligence, but I mean, particularly from my perspective, focusing on the United States. So that competition on talent is intensifying, not just within the US, between, say, federal entities and commercial entities, but it's playing out globally. Both Russia and China continue to pursue aggressive strategies to retain talent or to bring it back home, recognizing that talent is what drives many of these things forward. So even though we are facing, say, skill shortages in computer science and other STEM fields, the Department of Defense does face a lack of AI literacy that could very well lead, well, not just the DoD, but anyone in general. You know, that lack of AI literacy could very well lead decision makers to ask for AI and to put it where it's not appropriate. There's, I think, significant organizational change management issues that come into play when organizations and nations think about adopting artificial intelligence, because it fundamentally requires organizations to adopt a new technology, to adapt a new process, to adapt their incentives, to really bring it in. And if not everybody is on board, many of these initiatives fail. So within the DoD, we have seen some early success stories. We've seen projects and programs that are popping up that are successfully leveraging artificial intelligence. We've seen movement on addressing that shortage of STEM talent. So thinking about how do we bring in computer science talent and how do we retain it? The Air Force, for example, is using a program to essentially track and place computer language programming skills the way they would foreign language skills, as a way to say, this is a competency that we value, that we need to have. That model was actually expanded out to the other armed services with this most recent National Defense Authorization Act. So we're seeing those kind of stepping stones. those initial things or initial steps and progress towards bringing in artificial intelligence. But really, there's a broader challenge in how do we deploy this technology at scale? How do we not just go from small individual programs and projects that are successful, but really using it throughout the broader enterprise, which is really focused on not really challenges with the technology itself. I think this is always a unique aspect of when we talk about artificial intelligence. It always comes back to people, making sure that we have the right people both developing and using and deciding where it goes, that we have the right change management, the right hiring initiatives and incentives in place to get people in the door, but also to keep them there. And then simultaneously thinking about how do we adapt our defense procurement and defense acquisition systems to really deal with these new technologies that are software driven, that are coming from new places, that are not just coming from the big technology primes, but are coming from small data-driven firms, small startups, people that are new to that defense marketplace. So with that, I think there's a broad overview of what it is, what's going on globally, how are we thinking about it, and what are some of the challenges we're facing and how I think we're starting to address them. But I would love to open it up for questions and continue the discussion.
Lindsey, thank you so much. I really appreciate your insights and getting us started on this conversation about AI and national security. One question is coming right away from YouTube. Chinese authorities use facial recognition and AI technology. Some say that they're using that already in the fight of COVID-19. They actually control quarantines that way, some say. Do you think is that crossing a line in any way for human rights, that technology is used that way or not?
So I would say this is a question that we are continuing to grapple with and to debate with, not just from are we okay that China's doing it, but we do see significant movement and questions from more Western societies. I think it's important to situate the advanced technology that we've seen China deploy for monitoring the COVID-19 cases, for enforcing the quarantine. It's important to situate that within kind of their broader approach to facial recognition and the continuous surveillance, social governance, but also repression of a population. I know I have many colleagues that have done work on really how that digital surveillance and digital governance is really pervading our lives. There's one excellent report from Human Rights Watch that came out on, really digging into the meat of some of those Chinese systems. I will point out as an engineer, I'm also fascinated by how they're actually managing the data integration and really managing all of that. Anytime you're bringing large amounts of data together, there are significant technical hurdles that I'm sure they're focusing on and having to overcome. I will also note that China is not the only nation to lean in very heavily on facial recognition. London in the UK is one of the most heavily facial surveilled cities in the world. And it raises questions on opting in and opting out. At what point did you agree to this? Many European nations are coming out and coming out strongly against facial recognition. And I believe we have also seen that similarly within the US. Haven't seen a ton of top-down focus, but there have been cities within the United States that have come out and said, we are banning the use of facial recognition from a government perspective. I think there's also an interesting case in the United States, at least in particular, that I can think of, where we're a little bit more okay with commercial entities using facial recognition to either match consumer profiles with your person, to speed up the processing time at airports. And so we seem to be a little bit more okay with that from a commercial standpoint. But I think it really gets into this broader question of, and I don't have the answer, is we're all having to think about how do we think about data and digital governance? What data am I okay with people having and what data am I not okay with them having? And once we have a conversation and come to a consensus, how do we write effective policies that reflect that? And there is a significant lack of technical expertise at the policymaking level that can really drive that conversation forward. And so I think to some extent, we've kind of, the technology is running away from us, and we're kind of wondering, like, what do we do? But that's my response to facial recognition in China.
Wow. Yeah, thank you. Usually we think of AI as automating jobs, taking jobs away from people. You talked a lot about talent acquisition and getting people on board and working in this area, and we need to ramp that up. We need a lot of smart people to make this happen and happen well. Is this say something about how AI might change the future of work? Mostly we think about AI changing the future of work to the negative. We're gonna lose jobs, but you seem to be talking a little bit about it as a way to open up a new field for jobs as well.
I mean, it's entirely dependent on how you view the problem. And certainly we have seen studies that indicate that AI, and then there's another form we call robotic process automation, which is really just typically you don't lump it in with AI because then they get a little cranky when you put RPA in with them. But essentially that automating of very easy skills or very easy tasks on jobs. And so there are certainly cases where that automation does result in job loss. And I think that is something that we as a society are kind of failing to grapple with, because I don't think we're adequately preparing either those workers or the next generation for what the future of work is. But there's also a myth that we run into that AI, if you bring AI into your organization, it means you can hire less people. Particularly within the Defense Department, what we find is that it actually requires more people because it requires an entirely new type of skill, an entirely new type of professional to really build up these projects. And so every now and then you'll run into folks that will say, well, I'm going to bring in AI, I'm going to save a ton of money because then I can get rid of people. And we're like, well, that's actually not accurate at all. You're actually going to spend more money hiring more people, but you will have a greater capability. You'll have a system that performs above what it normally would. And we're even seeing areas where at least within the federal government, where there is not a loss of job. So one case study would be at the IRS. They brought in, they were able to automate some of their processes to help with compliance checks. And really, it relieved the burden on an already overloaded and overburdened workforce. And so essentially it was, this very repetitive or redundant task that takes 5 hours, I can now complete it in a couple of minutes, thus freeing up the time of that person who is already over allocated and overstretched to go do things that require more of the thought that is uniquely human. So that's not to say I don't think there is a consensus on AI will only result in job loss and AI will only result in job growth. But the one thing we can say for sure is that broadly across the board, we are seeing changes in the nature of work and the skills that are required to be a competent or to contribute. And I think a lot of organizations are thinking through, how do we upskill the workforce we have so that they can contribute in that way?
Thank you. How might AI shift the global balance of power, especially as we recover from COVID-19? And do you agree with Putin that whoever wins the AI war dominates the world?
I don't know if it's as simplistic as that. And partly because the ways in which nations are pursuing artificial intelligence, I don't know what it means to win the AI war. And that's partly because the ways in which nations are pursuing artificial intelligence inherently reflects their own national norms and goals and what they aim to achieve in the world. So if I'm looking at a one-for-one comparison of where is the United States looking at AI versus where's Russia looking at AI, it's probably going to look very different. And I don't know if I can do that one-for-one. I will say there is incredible economic advantage or an incredible economic leverage to be gained, and that is very much reflected in China's approach, is to basically be that AI center of gravity. If you abstract that a little bit more, it's just, how do I become the next Silicon Valley? How do I pull that economic center of weight in the technology sector and in technology innovation away from Silicon Valley to China? That would be a significant shift and balance of power. In general, it also allows new entrants into the market. It allows nations to kind of punch above their weight because it is a democratized capability in general. So there's a lot of reliance on open source software and models. You do have to have data, you do have to have computing resources for these large scale products, but it allows countries to kind of come into the global stage and the global economic stage and participate in ways that they haven't been before. Estonia is one really great example of this, which has really leaned very far forward on being kind of a kind of technology incubator and test bed. And they've worked out their regulatory approaches to essentially incentivize technology innovation to come out and test in Estonia. And so essentially building up this new economic model. So I think there's significant kind of economic dynamics that will play out on that, on how do we think about regional dynamics. Militarily, there's probably a little bit more to explore, but I'm a little bit more skeptical that we would see kind of like massive shifts there. I think I lean more towards, I think there's a lot of impact potentially on the economic side.
There's got to be this tug of war with the US and every country. The more AI is most effective when you have the most data and the most correct data. The more you have, the better your product will be. But sharing AI, sharing that data across borders has got to be a very difficult thing. I mean, how does the US go about assessing who it shares its information with, who it allows in to know what we're doing, and vice versa? How is that dialogue playing out globally?
Well, I think it's also important to remember, going back to the first part of your question, that AI does require a lot of data, but that data is inherently molded or kind of specific to that purpose. So and you'll often hear this played out with, well, China can gather so much more data on its population than we can in the United States. Does that mean they have an advantage? Well, that data is inherently representative of their population. It is more homogeneous to that group than it is to, say, other populations, and it's very specific to that purpose. So I think that's one area where I am more positive on data sharing among allies and among partners, is because you have that common purpose in mind. You're gathering data or sharing data for a common goal or a common purpose. As far as are there specific initiatives that I could point to? I mean, I know there's always, anytime we're talking about emerging technologies, interoperability is always a huge challenge among Five Eyes partners, which is probably more on the information sharing, as well as NATO. When you start thinking about how do you have equipment interoperability, that's always a huge challenge. So part of this is thinking about where are the security concerns? Is the security concern on the data? Is the security concern on the algorithm? Is it on the output? And that's actually really a bit of a new language for this community to have to think about. So it's very much a concern. It's conversations are ongoing. And I think we're seeing some initiatives around common goals that may be considered less secure, just to test it out and prove it out. So one initiative is through the United States established its Joint Artificial Intelligence Center in 2018, I believe. Wow, I can't believe it's 2020 already. Making sure I got that year right. And so essentially that is the organization within the Defense Department, under the Chief Information Officer, under the CIO, that is tasked with operationalizing AI for the department. And one of their first big initiatives was actually a partnership with Singapore's Defense Science and Technology Agency on humanitarian assistance and disaster relief, which would inherently involve information sharing, equipment sharing, co-research and development. So I think those are probably some of the areas where we'll see the most immediate moves is around these common goals, common approaches that may be a little bit less out of the very secure intelligence channels.
Great, thanks. Here's a question from Grand Valley State University. Mara Carolyn at the Brookings Institute suggests that using AI might have improved U.S. decision-making in instances where humans get trapped in wishful thinking, and examples maybe Vietnam or Afghanistan. Can AI help in those kinds of decisions?
I would say it can and it can't. So one thing that we always remember from the modeling and simulation community or from the systems engineering community, where you're building models about the world to either test out hypotheses or tell you things that you didn't know, is all models are wrong, but some models are useful. And so it's important to remember that when you're doing these types of explorations, that you come to that exploration with a question in mind. And you do the engineering around that question. What are the parameters I want to explore? What are the dependencies I want to explore? And so absolutely, I think Mara has an excellent point that did you come to those types of decisions with the right questions in mind? Could it allow you to explore aspects of that question that maybe you couldn't otherwise? I would also point out that there is the kind of the flip side of that, which is that oftentimes, and we'll see this in artificial intelligence as well, is you'll get kind of that information paradox. I have so much information available to me that I will continue to search for the perfect piece of information that will tell me when I have to make a decision. And so this is a phenomenon that particularly human-computer interaction specialists and cognitive scientists worry about when we think about bringing these big data techniques and artificial intelligence into decision-making processes, is could we actually incentivize people to not make decisions? Would they be so paralyzed by the troves of data available to them that they will continue to search for that perfect piece of information? And so I think yes, it is entirely possible that, artificial intelligence could be used to answer those hard questions. That requires somebody to ask the right question and to ask it well. And that is, as somebody who has led project teams on these tasks, that is it's much more difficult than it sounds. And so it's a balancing act.
Thanks, yeah. How can the Department of Defense ensure safety, security, ethics, that they're all at the forefront of capability development? How can they ensure that, this is done ethically, this is done the right way?
So I think the biggest thing is to tackle AI literacy throughout the enterprise. And I liken it to, in the Air Force, not everybody is a pilot and not everybody knows how to fix an airplane. They don't know the complicated things to repair an engine. But I can guarantee you everyone in the Air Force, from the contracts officer to the flag officer to probably the janitor, knows what an airplane is. They get the basic concepts. They understand how and when you use it. And that is a literacy that the force has. And until we have that level of understanding and literacy for artificial intelligence, I think we're going to continually grapple with where are the right places to use it. Is it mature enough? Are we using it correctly? Or are we using it incorrectly? I will say that I'm very heartened. I think the Defense Department has recognized, particularly, before the public blow up of Project Maven, but certainly since then, that they have a very real imperative, given the kind of myth and lack of transparency around these capabilities, to really be as far forward leaning with the public on how they're thinking about artificial intelligence. What does ethical use look like? And so the department generally recognizes this is a thing they have to do. So over the past year or so, the Defense Innovation Board, which is an independent advisory board of technology experts set up to advise the Defense Department on technology issues, conducted their study on the ethical use of artificial intelligence. The recommendation out of that was a set of 5 principles, the AI principles for ethical use of AI, as well as a significant supporting document that outlined not just, what is the same about AI, but what is different about AI, what are we really concerned about, how do existing policies and frameworks and guidance apply to artificial intelligence, like law of war requirements, like international law. And so that was put out by the Defense Innovation Board, and actually just recently the Department of Defense formally adopted those principles that will apply and guide how the DoD uses and develops artificial intelligence, specifically for that ethical use concern. That said, the devil is in the details. So how do we think about what does it mean to take this high level framework and apply it throughout the department? That's always a challenge, but I will say there is significant effort being put there. And again, I think the best way to protect against unethical uses, misapplications, is to really focus on the workforce and building up that literacy within the workforce.
One of the phrases that you used has really caught the attention of a number of our listeners. You said, it's not magic, it's mathematics. So could you expand on that a little bit? How much, is there anything more than math that's involved? What other disciplines might be involved with AI? And unpack that statement a little bit. It's not magic, it's mathematics.
Sure. I wish I could take credit for that statement, but that one has been around for a little bit longer than I have. But it came out of a particularly on the upswing, the AI hype cycle. So around 2012, researchers in Canada proved that we could get way better image recognition results using a machine learning algorithm that had previously been thought. And so that actually drew the attention of the computer science community, particularly in the commercial world, to say like, oh, wow, there's something really here to applying machine learning. I can, particularly in a commercial application, maximize profits or minimize returns. It can tackle these large volumes of data much more effectively than, say, like a brute force approach would, or traditional analytics or statistics. And so I think particularly within both commercial sectors that weren't necessarily technically minded, as well as the public sector, so the Defense Department, broader federal agencies, saw all of these this hype around artificial intelligence. So if you think about how you get targeted ads, how companies know what to suggest to you next, and they saw all of this like hype, and there was a real sense for many years of like, oh, well, I can, here's this problem over here, I'll just sprinkle some AI on it and magically everything will be solved. And there's a continual having to fight that narrative that you don't just sprinkle AI on your problems and now everything is better and all the problems go away. Having to really bring that back to it is math. So at its core, artificial intelligence is code. The algorithm is code, which is why we talk about really building up that computer science, competency. But you're absolutely right to draw the point that it is kind of also more than mathematics. And that's where we really wanted to capture by putting out a report on the AI ecosystem, that it's more than just the algorithm itself, it's the data. So am I gathering the data that I need? Do I have it in the right places? Do I have data in a usable format? So many of the challenges we find in the Defense Department are that my data may be spread out across 100 different servers, and I can't sprinkle the artificial intelligence on my data that is spread out over 100 different servers and actually have a good output. It's important to remember that it also, for some of these large scale applications, they require significant computing resources. And right now, I'd say there, one colleague, I think at NY, maybe she's not at NYU now. I can't think of where she is. And I've cited her before, so I could find it if you ask me to later. She basically asserted that, it was Meredith Whitaker, asserted that essentially only 5 companies can provide the computing power you need for large scale for large scale machine learning problems and solutions. So looking at who can provide that cloud computing capability, Google, Microsoft, Amazon, so those types of entities. So absolutely, you have to have that computing infrastructure. You have to have the workforce. You have to have the right hardware and software, so and permissions. So an example we have in machine learning, Python has kind of turned into one of the most widely used computer languages. But at the Department of Defense, you don't get a computer with Python installed, and you certainly don't have the permissions to install it yourself. So when we talk about, you can't just sprinkle AI on it. It's mathematics. It's also all of the stuff around the technology. It's that ecosystem. And if that ecosystem isn't prepared, then you certainly can't sprinkle AI anywhere.
Thanks. Are we in a hype stage of AI? What are the possibilities and what are the limits of AI? Do you delve into that a little bit more?
Yeah, so I think so we're certainly in a hype stage. My sense is that the hype may be cooling a little bit. And so there's a lot of concern, particularly within the artificial intelligence community. They have gone through 2 AI winters where we went through this hype cycle. And so this is going back to, decades ago. So we went through this hype cycle of increased hype. Artificial intelligence is, again, it's magic. We can put it wherever we want. And then once those dividends were not returned and once kind of the hype was not realized, there was a significant drop off in funding and research. So we saw one phenomenon, I believe in the 80s or so, around what we call expert systems. And so this would be systems that are very rules based. So they, if this situation, then that output. And that requires a human to go in and code all of those rules. And it's actually really funny if you go back and research the history of artificial intelligence, particularly within the Defense Department, you can find papers from that hype cycle. And I kid you not, they basically could be written today about where we are with machine learning. You could take out a couple words and you would have thought that it had popped on my desk last week. And so there is kind of a concern that we're potentially going to kind of hit that point where artificial intelligence isn't going to deliver. I think broadly, artificial intelligence, particularly machine learning, computer vision and natural language processing, the dividends that have been paid by machine learning in the commercial sector, I don't think we'll see a huge drop off. We may get to a point, and I believe there is concern within the community that we'll kind of hit the limit with what machine learning can actually do, but it's still going to be here. I think one of my biggest concerns from a national security perspective is the amount of work that has to go into kind of preparing the ecosystem. So getting the right workforce, the IT modernization, getting all of that in place. Some of the quirks and features of our budgeting process, such that when I start planning for projects this year, they're not going to come online and get dollars until 2022. So organizations having to justify where they're putting their money, the Joint AI Center having to justify its existence, that it deserves and is using wisely the budget it has, the staff it has. I worry that because a lot of this requires building momentum and inertia, we could kind of see a cooling. within this particular area. But I think broadly, we won't see as big of a winter as we've seen before.
What are, for our students out there, what are some of the skills that one needs to prepare for this reality of AI? Besides math and computer science, how is it helpful to have a background to get into this field? What were some of the things that helped you on your career path?
Well, I think it's important, and I believe I may have actually ignored this in the previous question, so I apologize for that. AI is really very multidisciplinary. So the number of times we'll talk about, it would be really great if a computer scientist went and took like one class on ethics or one class on sociology. Like even that would be great. But I think in general, it's been a really fascinating transition for me to watch because coding, being competent in computer languages is really becoming more of a given. And I think back to my early days when I was applying for jobs, and I would put on my resume, like proficient in Microsoft Office. Like I knew Word and PowerPoint, and I knew Excel, and I could code in VBA. So like if I actually needed to do macros, I could do that. And you don't put that on your resume anymore because it is a given. You have to have those skills to participate in the job market. I'm always amazed at the level of skills and talent that we have coming from interns and from new hires at CSIS. So we do hire primarily from the social sciences, from economics, political science, international relations, international security. But most people know at least one computer language. Most people are competent in R or Python if they're a little bit more into the data science. So I would say, absolutely be thinking about building up those computer language competencies, being proficient. It's certainly a skill that is beyond just engineering. I see it now that I'm in a policy environment. But I would absolutely say, I encourage, getting out of your comfort zone and getting into a different field. So when I was in undergrad and I was in aerospace engineering, everybody looked at me very strange that I went into the international security department and took classes. But I really enjoyed the classes, and so it was fun. But it really allowed me to have that understanding of not just how is what I'm doing in engineering going to impact international security, but like, how can I frame what I'm doing in this broader context? So I would certainly encourage, particularly while you're in university and you have the ability to, expand your, the classes you're taking and expand your aperture, like absolutely take advantage of that. But even for students in the social sciences, I think you really need to, learn how to code, and that will certainly serve you well, at least if you come to DC, because everybody is looking for people who can code.
It's interesting because you, in your remarks, you talked about computer languages like foreign languages. Now, I think students nowadays are cognizant that they should have one or two or three languages that they can speak, but you're talking in terms of computer languages that same way, that they should have a portfolio of how they can speak in those terms.
Absolutely. And that example was a big step forward, I think, for the Air Force. And then it was very heartening to see that get expanded out. But it was the Air Force's recognition of, how are we going to use these emerging technologies? They're all software driven, they're all written in code, but we don't even know who in our force knows how to code. And so it is that recognition that this is a competency like foreign languages. It is mission critical. It is one that, if you know how to code, you need to be put in a job where you can use those skills. Like a foreign language, programming is use it or lose it. I haven't programmed in a few years, and I don't think I could work my way around a computer anymore. So it's very much like foreign language. You kind of have to continually be learning and building up your chops.
Lindsey, you mentioned that there's some shift in the DoD budget, that AI is getting more funding and that other disciplines lost some funding or whatever. what specifically, what areas of AI, what areas in R&D will be using that, and what did the budget lose because they were shifting into AI?
So I haven't seen the proposed budget coming out of DoD for their research focus. The budget that I was referencing was earlier this year. The president puts out his presidential budget request, and that is for all federal research and development. And so we saw two big winners. Artificial intelligence received an increase of funding, and an increase in funding proportional to the broader, pie. They got a bigger piece of the pie. In addition, quantum computing also got a concerted focus, which I think is, I think that's very important for quantum. We are still very early days on demonstrating even the feasibility of that capability. And so it does require that sustained investment. However, across the board, we saw for another year in a row, this is a many years trend of a decrease in federal funding on research and development. So that was significant cuts to the National Science Foundation, particularly on the social sciences. We saw significant cuts to the Department of Energy. One notable one is, so the Defense Department has DARPA, their Defense Advanced Research Project Agency. The Department of Energy likewise has their ARPA-E, so their Advanced Research Projects for Energy. And that budget line, I think, took a significant hit. Aside from, the pieces of DOE that maintain the nuclear weapons, it was kind of a significant cuts across the board there. On the defense side, we did actually see the Defense Department entirely cut out its Minerva program, which focused on social science research for defense applications and for defense questions. And so I think that's an incredibly, yes, it's great that artificial intelligence got a big boost. And it's not just artificial intelligence, the technology, it's focused on workforce initiatives, on IT initiatives. Quantum got a big boost, which is good. But I think the overall downward trend of research and development from the federal government is incredibly concerning, particularly at a time when we see other nations are only increasing. And so that tells me a little bit of something about where we're prioritizing putting our dollars. Part of that strategy is a recognition that we have a robust commercial sector. So in particular, this administration is highly prioritized leaning on commercial. How do we get commercial solutions into the government so we're not reinventing the wheel, letting them do the research and development? But that does not recognize or reflect the role that federal R&D has traditionally played, particularly in basic research and development. So building that foundation that then commercial can go apply. But also I think, significant cuts across the social sciences board will have reverberating impacts across academia. And I'm very disheartened to see that.
Wow. Well, maybe it's because, all the sports leagues are getting cut or paused, during COVID-19. But, if the Houston Astros won the World Series a couple of years ago by coming up with a cheating device, is AI, is that the next thing for baseball? Is somebody going to figure out how to use AI and be able to predict their way and AI solve their way to a World Series?
I certainly would not be surprised given the role of data analytics and how data heavy baseball is. I have heard stories of leagues using AI, so machine learning and computer vision, for doing just basic video viewing of games. So like in basketball, determining was that an out ball or was it in? Because all you need is a computer to say, like, did the ball cross the line? So I think there will be some really interesting applications. I can't really speak. We're Georgia Tech. It's just a continued heartbreak. So we'll see where that goes.
Yeah, you think Georgia Tech would have a number of national championships by now because
We do. We have 4.
Okay.
We have more than UGA, and that's all that matters for us.
Lindsey, thank you very much. You've been brilliant. It's been very, very interesting talking with you and conversing, hearing about artificial intelligence and national security and beyond. So best wishes to you
Well,
in your
thank you so
work.
much.
Keep doing the good things that you're doing,
You
and
as well.
we'll stay in touch with you.
Yeah, absolutely. And like I said, so they can follow my work on CSIS.org. I have an expert profile. I am also on Twitter at Lindsey Sheppard. And so I'm active, and I'll usually post interesting things that I find, but always happy to engage with folks that way if there are continued questions and discussions to have.